Implementing social authentication is really straightforward when it comes to Node.js, thanks to a fantastic module called Passport. Built by Jared Henson, Passport is an incredible authentication enabler that is not only easy to use, but allows developers to pick and choose from over 300 authentication providers and strategies. It also supports sessions out of the box, which means that user data such as user ID can be stored in the session once fetched from the authentication provider and can then be used to obtain further user-centric elements such as profile picture, email ID, etc. What's more is that you can implement any combination of authentication strategies from the huge 300 plus options that you get. And if that is not sufficient, you can build your own authentication strategy as well. For our app, we'll provide our users with the ability to log in using either Facebook or Twitter. From these providers, we will fetch the user's name and profile picture. What is important to understand in this entire process is that an authentication strategy depends on an authentication standard which provides a complete end-to-end workflow for third-party apps to authenticate and get access to user data. Facebook, for instance, uses the OAuth 2.0 standard. OAuth is an open authentication standard and Facebook uses version 2.0. On the other hand, Twitter still uses the old 1.0a standard. Over the next few slides, we'll see how these standards work, but the really interesting bit for us as a Node.js developer is that Passport provides us with a uniform workflow for most authentication standards, and it abstracts the underlying differences in implementation. This is a massive time saver. So let's see how OAuth 1.0 and 2.0 work. They're a bit different in how they approach the process. Let's begin with Twitter's implementation of OAuth 1.0a. The first thing that you do is register your app, such as our ChatCat app, with Twitter. Over the next few screencasts, I'll demonstrate how this is done. Once you register the app, Twitter will provide you with two unique IDs, namely a consumer key and a consumer secret. So the first thing that our app needs to do is to access Twitter's authentication API and ask for a request token. When this request is made, your app needs to also pass in the consumer key, consumer secret, and a URI for Twitter to reach back to your app. So step number 1, we want to obtain a request token. Twitter then checks to see if the requesting app with the given consumer key and secret is registered or not. If so, Twitter generates a request token, which is also like an ID, and sends it back as a parameter to your app using the callback URI, which we had provided in the beginning. So step number 2, we get the request token from Twitter. Your app then has to take that request token and once again submit it to Twitter. This assures Twitter that your app is indeed eligible for proceeding forward with the authentication process and that you're not a bot or some other malicious piece of code trying to gain access. At this point, Twitter displays a dialog box to the user and asks the user to log in using his or her Twitter credentials. Once the user does so, Twitter will ask the user if he wishes to grant access to his profile data to the requesting third-party app, that is, your app. If the user grants this access, then Twitter once again returns back to your app, and this time it sends along a verifier code. The verifier code essentially tells your app that the user has granted access. Your app then takes that verifier code and once again sends it to Twitter. At this point, Twitter understands that the user has granted access to the third-party app, and this time Twitter sends back an access token to your app. This access token is extremely important because from this point onwards, whenever your app needs to request any piece of data from Twitter, such as the user's profile pic, name, tweets, etc., it can do so by sending this access token along with the request to Twitter's API. Since the access token is time-bound and expires, it is secure and your app can thus get access to the user's profile. What is important to understand here is that this complicated mechanism is in place to prevent malicious attacks, since authentication is a sacred process that cannot leave any room for error. So in a nutshell, we get an access token at the end of the process, and our app uses that to obtain user-centric data from an OAuth 1.0a provider such as Twitter. Now, when we come to OAuth 2.0, such as in the case of Facebook, the process becomes a bit easier. OAuth 2.0 delegated much of the security-related issues to the use and implementation of the HTTPS protocol. In this case, your app first makes a request to Facebook and sends along an app ID and an app secret. This is similar to the consumer key and secret which we used in the case of Twitter. And once again, you need to register your app with Facebook before you are provided with these IDs. So once your app sends these IDs to Facebook, the user is shown the Facebook login screen. Once the user logs in, Facebook asks the user to grant or deny access to the third-party app. You're also told about the features of the profile that the third-party app wishes to access. This request scope is also something that we send along when we initiate the authorization sequence with Facebook. If the user grants access, then Facebook sends back an authorization code to your app. Your app then sends this authorization code back to Facebook, and at this point, Facebook is assured about the authenticity of the request and it grants an access token, which is then sent back to your app. All further calls to the Facebook API are done using this access token. A refresh token is also sent along for renewing the access token when it expires. Now, both the OAuth 1.0 and 2.0 workflows look pretty complicated, and to an extent they are. Fortunately, Passport abstracts all of these intricacies. The Passport workflow looks like this. You begin by invoking the passport.authenticate method, where you pass in the name of the authentication provider. This invokes a strategy method which contains all the implementation processes. To the user, you straight away get to the Facebook or Twitter login page. Once you log in and grant access, control returns back to your app along with the user data. Passport then allows you to search and store this data in a local database such as MongoDB, and it also stores the unique object ID in the session. Note that actual data is not stored in the session, but just a unique ID that is associated with that particular user profile. Whenever the app requests this user-centric data such as the username, profile pic, etc., Passport fetches the object ID from the session and uses that to query the local database, from where it fetches the user data and injects it into request variables, which can then be easily accessed and displayed on a page. Since request variables are available within route handlers owing to the request and response streams, this is extremely convenient and easy to implement. I hope you now have a firm footing on how social authentication as a process works. You also saw how the OAuth standard functions. Armed with this knowledge, let's jump back into code and implement Passport.js in our chat application.